Okay, so this test, if you haven't figured out, this is for an RFID project. It's actually an RFID exploit as far as reading a tag at a distance. Me and another guy hold a record for the longest read of over 25 feet from the door sensor. So this is basically emulating a door sensor. It's providing a signal so that when I place a tag over the top of it, it basically becomes a modulator. So that modulation is able to be picked up by this second coil with the proper circuitry. And what you see on the scope right now, it's kind of, it looks chaos, it's noise. So, but it is picking up the 125 kilohertz signal. So if I go over here to this circuitry and I remove that, the signal basically goes away. And what you still see is noise, but the purple line is gone. So I reattach that, purple line comes back, and then what you're seeing, this noise floor right here, is actually after the decoder basically filters out the 125 kilohertz, it's left with just the noise that is on the tips of the sine wave. So when I put a tag on top of here, it will basically, it modulates the signal so that, I'll take the tag off, you can see it's noise. I'll put the tag on, it cleans it up a little bit. Now, since it's 125 kilohertz across here, what I can do is I can adjust the scale of this. So now this, the bottom, the yellow, becomes more apparent that it's the data. Excuse me, that's the data from the card itself. So the card is modulating over here. This coil is picking it up. This circuitry here is conditioning the signal. There's an amplifier, a regenerative amplifier for the 125 kilohertz, and then it goes through other different stages where it filters, amplifies, and basically it gets to a point where it doesn't need the 125 kilohertz anymore, so it filters that out. So all you're left with is the modulated signal that rides on top of the 125 kilohertz carrier. And so that's what you see here as far as with the yellow. That's the actual data for the card. Now I can take this sensor and I can raise it. You can see that it goes down, but the data is still present. I can get about 2 feet away right now with this setup from the top to the bottom coil, as far as this bottom coil picking up the modulation that's being given off by what this is simulating as a door sensor. So when you badge in and put your badge on the door, your tag is basically being modulated by the door sensor. And so from that modulation is able to be picked up by this coil, and like I said, fed into the scope. And by decoding the code, we can pick off what the actual code for the tag is at a distance. Now this is just a demo for test purposes. Well, not test purposes. We're putting together kits, so it's limited as far as how much of a range you can actually get. Maybe 3 feet, maybe 4 feet. There are ways to improve it, but these are the bones as far as what you would need to put something like that together. So I'll be releasing a book that goes along with this at some point that basically tells the whole story as far as how things came to be back in 2014 when we set our record at 25 feet as far as a valid read. So that's what this is part of, basically bringing this project back to life with new and more improved circuit design and a more up-to-date microcontroller that we're using for the system. So that's kind of where things are at. Thanks for watching.